Hello everyone. Welcome to Sally and Bytes, where we make learning technology fun and simple. Today, we're diving into the exciting world of computer networks. Whether you're working remotely, streaming your favorite shows, or managing a smart home, you're using computer networks every single day. Ready to explore? Let's get started. Networks play a critical role in our everyday lives because they form the backbone of communication, commerce, and information exchange. Social networks, platforms like Facebook and X, formerly Twitter, connects millions of people. Mobile networks enable calls, texts, and mobile data. Healthcare networks connect hospitals and labs for sharing medical data. Airline and railway networks handle ticket bookings and schedules. Banking networks enable ATM withdrawals and online transactions. Apart from these, the most extensively used feature is the print command sent from a computer to get a printout from a printer attached to some other computer. All this involves a network. It is the network that connects various computers to each other and handles a large volume of data. So, what is a computer network? A computer network is a system where multiple devices, such as computers, smartphones, servers, and even printers, are interconnected to work together. How these devices connect in a network. These devices are linked through wired connections, using Ethernet cables to transmit data. Or wireless, using radio signals, such as Wi-Fi or Bluetooth. An Ethernet cable is a type of network cable used to connect devices, like computers, routers, and switches, in a wired network. It enables fast and reliable data transfer by transmitting information in the form of electrical signals. Example of Ethernet cable usage. Home network, connecting a computer to a router for a stable internet connection. Office network, linking multiple computers to a network switch for file sharing and printer access. Gaming, connecting a gaming console or PC to the internet for low-latency online gaming. Wi-Fi is a wireless technology that allows devices to connect to the internet or communicate with each other over a local network without using cables. Bluetooth is a short-range wireless technology that enables devices to exchange data directly with each other over a small distance. Standalone device. A standalone device is any mechanism or system that performs its function without needing another device, computer, or network connection. An example of a standalone device is a copy or fax machine. With a computer, a standalone computer would be a computer that's not connected to a network. Two computers or devices are said to be interconnected if they can share and exchange information by following a protocol. Now, what is a protocol? Think of it as a set of rules or guidelines that these devices must follow to communicate effectively. Just like humans need a common language to understand each other, devices in a network use protocols to exchange information. For example, HTTP, Hypertext Transfer Protocol, is the protocol your browser uses to load web pages. SMTP, Simple Mail Transfer Protocol, is used to send emails. TCP or IP, Transmission Control Protocol or Internet Protocol, is the foundation of communication over the internet, ensuring data is sent and received correctly. Think of a computer network like a postal system for the digital world. To get it to the right person, the letter travels through a series of steps, from the post office to sorting centers and then to the recipient. Similarly, in a computer network, data is sent in tiny packets, traveling through routers, switches, and servers before reaching the right device. Let's see an example of the postal system. Let's say you're sending a birthday card to a friend who lives in another city. You write the card. This is like creating data on your device, such as an email or a file. You put it in an envelope and address it. This is like packaging the data into packets with the destination address, IP address. The postal system delivers it through various routes. Just like how routers and servers guide data through the network. It reaches your friend's mailbox. This is like the data being delivered to the correct device on the network. What is a node in networking? A node in networking is any device that can send, receive, store, or process data within a network. The types of nodes in a network are end devices and intermediary devices. Let's see the types of nodes in detail. End device nodes. End devices are devices located at the edge of a network. The edge of the network refers to the point where users directly interact with the network using computers, smartphones, and other devices. These end devices are used to send, receive, or process data and perform specific tasks by directly communicating with the network. Let's see the examples of end devices. Computers like laptops, desktops used for browsing, sending emails, and running applications. Smartphones and tablets connect to the internet for communication and entertainment. Printers and scanners receive and process documents from computers. IoT devices like smart thermostats, smart lights operate based on network signals. Servers store and provide data to clients. Let's see about the intermediary nodes. Intermediary nodes are devices within a network that facilitate communication by forwarding, processing, or managing data between end devices. They do not generate data themselves but help in routing and security. Let's see the examples of intermediary nodes. Routers, a node that directs data between different networks, for example, home network to the internet. Let's see an example of a router in action. When you connect to Wi-Fi at home, the router takes the request from your phone, sends it to the internet, and brings back the requested web page or video. Switches, a node that connects multiple devices within a local area network, LAN, and forward data efficiently. Let's see an example of a switch in action. In an office network, multiple computers are connected to a switch. When one computer sends a file to another, the switch directs the data only to that specific computer, preventing unnecessary traffic. Hubs, a node in a network that facilitates data transmission and broadcasts data to all connected devices. Let's see an example of a hub in action. In a small office network, a hub connects for computers. When one computer sends a file, the hub forwards it to all 4 devices, even if only one needs it. Modems, a node that provides internet access by converting signals. A modem, modulator-demodulator, is a networking device that converts digital data into analog signals for transmission over communication lines, like telephone or cable, and converts received analog signals back into digital data for computers to understand. Let's see an example of a modem in action. A modem is used in remote villages to provide internet access via mobile networks, enabling online learning for students. Access points. An access point, AP, is a networking device that extends a wired network by providing wireless connectivity, Wi-Fi, to devices. It connects to a router via an Ethernet cable and allows wireless devices to access the network. Let's see an example of an access point in action. In a large office or school, multiple access points are installed to ensure seamless Wi-Fi coverage across different rooms and floors. Firewalls. A firewall is a network security device or software that monitors, filters, and controls incoming and outgoing network traffic based on predefined security rules. It acts as a barrier between a trusted internal network and untrusted external networks, such as the Internet. Let's see an example of a firewall in action. A company's firewall blocks employees from accessing unsafe websites and prevents cyber attacks from entering the network. Now, pause the video and take a moment to identify the end devices and intermediary devices in this interesting scenario. Think about which devices are sending or receiving data and which ones are helping to transfer it across the network. Understanding the basics of computer networks. A basic network may connect a few computers placed in a room. The network size may vary from small to large, depending on the number of computers it connects. A computer network can include different types of hosts, also called nodes, like server, desktop, laptop, smartphones, printer, etc. Let's see about the home access network. Imagine your home Wi-Fi. When your smartphone, laptop, printer, and smart TV are connected to the same Wi-Fi, they form a small network. This network allows you to share resources, stream a video from the internet to your TV, exchange data, send a file from your laptop to your printer, communicate, make a video call on your smartphone using the internet. Wi-Fi, short for wireless fidelity, is a technology that allows devices to connect to the internet wirelessly using radio waves. In a residential environment, home access networks enable connectivity by using technologies like DSL, digital subscriber line, cable internet, or fiber optic connections to link homes to the broader internet. DSL, digital subscriber line, a technology that provides internet access by transmitting data over traditional telephone lines without disrupting voice service. DSL is a communication medium used to transfer high-speed internet over a standard copper wire telecommunication line. Cable internet, a broadband internet connection that uses the same coaxial cables as cable TV to deliver high-speed internet to homes. Fiber optic internet, a high-speed internet connection that transmits data using light signals through thin glass or plastic fibers, offering faster and more reliable performance than DSL or cable. Wi-Fi works through a router, which distributes these internet signals wirelessly to your devices, providing fast and convenient internet access without the need for cables. Let's see the uses of computer network. Computer networks can be used for different purposes in our daily lives. Resource sharing. The primary use of a network is to share programs and applications among users, share data across the network, share peripheral devices, like printers, scanners, and accessibility is possible irrespective of physical location. Devices can share hardware, like printers. For example, suppose all the students in your class are in the computer lab, each student using an individual computer. The teacher has asked all the students to print an article on the topic, Role of Communication in Everyday Life. Will you want a separate printer for every computer? The answer is no. You can observe that only one printer in the lab will be shared with all the students, and this is possible only because of the computer network. This is called resource sharing. Other resources like hard disk, DVD drive, scanner, etc., can be shared on a computer network. For example, sharing databases, audio and video files, antivirus software, application software, printers and scanner, etc. File sharing. Devices can share software, like shared files or applications. For example, you can share any file with your friend who is located remotely in a different country. Exchanging data. Connected devices can send and receive information seamlessly, whether it's sharing a document or streaming a video. Improved communication. The network allows devices to communicate with each other, enabling activities like messaging, video calls, or collaborative work. For example, in an organization, managers work at different locations to make financial reports. While working on a network, any change made by one manager on his or her computer can easily be seen by other managers and employees. Thus, a network allows managers to easily update information. This increases their efficiency and allows them to complete their work quickly. Database access. Computer networks enable multiple computers to access the same database, enhancing data storage capacity and providing easy access to stored data. Security. Suppose you have stored your class assignments on the network. Your data is secured on the network because a network key, password, is provided to the user to access that data. Reliability of data. Reliability means backing up of data. What if you accidentally delete one of your project files from your individual computer in the network? Do not worry. In computer networks, the data is stored on a central computer, known as the server. The server keeps a backup file of everything that we store in it. So, backing up data is also a benefit of computer networks. In case of data loss, you will have a backup copy of your data. Let's see the advantages of computer networks. Reduced communication cost. Sharing resources reduces communication costs. In this image, you can see a shared printer and shared software, which help reduce communication costs. Using public networks, we can send a large quantity of data at a low cost. For example, internet and mobile networks enable people to send and receive data such as text, images, audio, and videos at a low cost, making communication easy and affordable worldwide. Less data redundancy. Less data redundancy means that the same piece of data is not stored multiple times unnecessarily within a system or database. Reducing redundancy helps in saving storage space, improving data accuracy, and making data management more efficient. For example, imagine a student database in a school. Without redundancy, each student's information, like name, address, contact, is stored only once. With redundancy, the same student's name and address are repeated in different tables for attendance, exam records, and fee details. How to achieve less data redundancy? Database normalization, organizing data efficiently to avoid duplication. Using unique identifiers, like student ID numbers instead of repeating personal information. Centralized databases, keeping data in one place instead of scattered systems. Less data inconsistency refers to a situation where data remains accurate, reliable, and uniform across different systems or databases. It means that there are fewer contradictions or discrepancies in the stored information. For example, imagine you have an online shopping app. Database 1 shows a product has 20 items in stock. Database 2 shows the same product has 15 items in stock. This mismatch is called data inconsistency because the same product has different stock values in different places. When we say less data inconsistency, it means the system is well managed, and such mismatches rarely occur. This is achieved through data synchronization, keeping data updated in real time. Centralized databases, single source of truth, which means all departments or users access the same data from one place. Proper data validation, checking for errors. Data centralization is the process of storing all data in a single, central location, such as a central database or data server. This makes it easier to manage, access, and secure the data, ensuring consistency across an organization. Key features of data centralization. Single source of truth, all departments or users access the same data from one place. Improved data consistency, reduces errors because data updates are reflected everywhere instantly. Easier data management, simplifies backup, security, and updates since everything is in one location. For example, imagine a university with multiple departments. Without centralization, each department, admissions, finance, academics, stores student data separately, leading to duplication and mismatches. With centralization, all departments access student data from a single database. If the student updates their phone number, it's updated everywhere automatically. Benefits of data centralization. Data accuracy, no conflicting versions of the same data. Stronger security, easier to control who accesses sensitive information. Efficient decision-making, faster data analysis since everything is in one place. Data recovery is the process of retrieving lost, deleted, corrupted, or inaccessible data from storage devices like hard drives, SSDs, USB drives, CDs, or cloud systems. It's often used when data is accidentally deleted, systems crash, or hardware gets damaged. When is data recovery needed? Accidental deletion, files are mistakenly deleted and removed from the recycle bin. Hardware failure, hard drive crashes or SSD malfunctions. System crashes, operating system errors causing data inaccessibility. Virus or malware attacks, data gets corrupted or encrypted by malware. Natural disasters, fire, floods, or power surges damaging storage devices. How does data recovery work? For deleted files, the data isn't immediately erased. Recovery software can restore it if not overwritten. For corrupted drives, specialized tools repair file systems to make data readable again. For damaged hardware, Experts use advanced techniques in clean labs to recover data from physically broken devices. Data recovery methods. Software-based recovery, tools like Recover, EaseUS, or Stellar for accidental deletion. Backup restoration, recovering data from previous backups, cloud, external drives. Professional data recovery services, for severe hardware damage. How to prevent data loss. Regular backups, use external drives or cloud storage. Use reliable antivirus, protect against malware. Avoid physical damage, handle storage devices carefully. Power protection, use surge protectors to prevent power-related damage. Let's see the disadvantages of computer networks. Cost of setup and maintenance. It is difficult to set up larger networks as the systems on a network are sophisticated and complex to run. Even cabling and equipment cost can be expensive. In addition to this, maintenance cost may be very high for larger networks. Threat to data security. Unauthorized access to data, leading to data theft or corruption, along with malware and phishing, are some of the major threats to network security. Let's understand the key terms. Unauthorized access. When attackers gain access to a system without permission, they can steal, modify, or destroy sensitive data. Data theft. Cybercriminals may steal personal, financial, or business data for fraud, identity theft, or selling on the dark web. Data corruption. Malicious actors may alter or damage data, leading to system failures or loss of integrity. Malware, a broad term for any malicious software designed to harm, exploit, or disrupt systems. It includes viruses, worms, ransomware, spyware, and trojans. Computer virus, a type of malware that attaches to files or programs and spreads when the infected file is executed. It requires user action to propagate. Worm, a self-replicating malware that spreads across networks without needing a host file or user interaction. It exploits security vulnerabilities to spread. Phishing, not a type of malware but a cyber attack that tricks users into revealing sensitive information, for example, passwords, financial details, through fake emails, websites, or messages. Let's look at some real-time examples. Social media. When you send a message on WhatsApp or post a picture on Instagram, your device connects to a network to send that information. Your message travels through multiple devices and servers before reaching your friend, even if they're halfway across the world. Gaming. Gamers, this one's for you. When you play games like Fortnite or Minecraft, your console or PC connects to a network to exchange game data in real time. This allows you to play with friends across cities or countries. Remote work. During a Zoom meeting or while collaborating on Google Docs, your devices connect to a network to share files, audio, and video data in real time. That network might be your home Wi-Fi or your office's private system. Online shopping. When you purchase something on Amazon, your computer sends a request over the internet to Amazon's servers. Within milliseconds, it retrieves information about products, availability, and payment processing, all thanks to interconnected networks. Smart homes. In smart homes, networks connect devices like thermostats, security cameras, and voice assistants, e.g., Alexa or Google Home. These devices communicate with each other, making your home more efficient and automated. So that's a quick introduction to computer networks. Don't forget to like, share, and subscribe for more Tech Made Easy content. See you next time.